Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's geometry class. Today we're going to start a little class opener, make sure that concepts are coming together. First question here is angle STR a right angle? Is STR a right angle? How am I going to figure this out? This is why or why not? What do you guys think? What's going on here? What do we know for sure? What can we assume? Yes, sir. No, we cannot assume anything about STR. Sorry, no offense. Yes, sir. That you can do. You can assume that ETR is a, and what is the angle measure of a straight angle? Excellent. So we know that 120 minus 3x plus 60 plus 3x equals 180. Okay? 180 equals 180. Okay, but, huh? Did I do something wrong? Hold on. All right, guys, I just had a little blurb there, but yes, 180 equals 180. This goes back to algebra. What happens when one side equals the other side? There are infinitely many solutions for x. So since x can be any real number, okay, it can be any real number, both sides are going to be equal. So that means that if in total they're 180 and each side is equal, that means that 180 divided by 2 has to be 90. So therefore, this is 90 because they're not asking you to solve for x. So that has to be 90. And yes. And again, why? Because x can be any real number and both sides are going to be equal. And if both sides are equal on a straight angle, that means that 180 divided by 2 has to be 90 degrees. Okay? And then I made a little bit fancy. X can be any real number, therefore STR can be a right angle if and only if x equals 10. Okay? Does that make sense? Thank you, my brothers. Now, here. I've got that angle MBA. Remember what I talked about yesterday. Label, label, label. MBA is 84 degrees. And then ABO is 42 degrees. I want to prove that MBO, okay, is congruent to ABO. Well, how am I going to do that? Always use your givens first. So we've got MBA, angle MBA is 84. That's a given. By the way, on what I saw in your papers, most of you answered that correctly. Good start. I'm not even being sarcastic. That's a good start. Next, ABO equals 42. That is also given, gentlemen. But now, think about why I labeled this. MBA is the whole entire angle. ABO is this little green part of the angle. Okay? I want to prove that MBO and ABO are congruent. Well, think about it. MBO has to be 42 degrees. Why? Because of subtraction. If the whole thing is 84 minus ABO, which is 42, that means I'm only left with 42 degrees left, which is MBO. So if MBO is 42 degrees, and we know that angle ABO is 42 degrees, then that means that MBO is congruent to ABO. Why? Why?
Angles that are equal.
Thank you. Angles with, why is this? Okay, I didn't put it down there. Angles with the same measure are congruent. Does that make sense? There it is. Two angles have the same measure, they're congruent. Yes, sir. No. Well, yes. There will be some times that there are things that there's just not enough information. But that's going to come down later in the year. Okay? All right, guys? So that's our little start. Yes, sir. Conclusion and proof is the same thing as I mentioned yesterday in class. Okay. Let's start 1-5 then, guys. In 1-5, I'm going to split this in half, if you've noticed in your homework, okay? We're going to first learn about bisectors, and then later we're going to learn about trisectors, okay? So, Division of segments and angles. A segment bisector, guys, is a point, segment, line, or ray that divides or cuts a segment into two equal halves, or in other words, into two congruent segments. Bless you. And that point, that segment, or that line, or that ray goes through one specific point called a midpoint. Okay? The midpoint is the actual bisection point on the segment where the segment bisector is located. Okay, so the midpoint is the actual location of where it's located. Make sense so far? Okay, awesome. Now, let's continue. If you look at the little figure that I have down here, okay, this side is X and this side is X. That means that they were cut into two equal halves. And the point here in the middle that actually cuts that segment into two equal or congruent halves is called the midpoint. That is the bisection point. And remember, that midpoint can be created by putting a point or a line or a segment or a ray. Basically anything that cuts a segment into two halves, okay? That's a segment bisector. And the location at which it cuts that segment in half, that is called my midpoint. And funny thing about midpoints, only segments can be bisected and therefore have midpoints. A line goes on forever and ever and ever, and therefore cannot have a midpoint. Okay? It just cannot. So far, so good? Okay. Now, let's prove it. Look at a little proof here. In this case, if XY bisects AC at B, what conclusion can be made? Well, what can I tell about point B here? Sir? Yes, absolutely. B is the midpoint of AC. And if B is the midpoint of AC, my brothers, what can I tell about AB and BC, guys? Think about it, guys. If B is the midpoint, what can I tell about AB and BC? That they're the same. They are congruent. Remember, guys, we're in geometry now. We can't say they're the same anymore. We have to say they're congruent. So if B is the midpoint of segment AC, that means that AB must be congruent to BC. Does that make sense, gentlemen? Okay, awesome. I know I'm flying here, but there's only two more examples that I'm going to do with you guys for today. And then tomorrow, we're going to finish up 1.5 by talking about trisectors. And hopefully that will, make it a little bit easier. I knew that this was going to be a long day. So, I'm going to continue. I am sorry, but remember, we do have a video. Okay, number 2. If D is the midpoint now of FE, what conclusions can be made? So if D is the midpoint, what do we automatically know about FD and FE? They're congruent. Absolutely. FD must be congruent to DE. Now we know that D is the midpoint, but what does that mean? How does D affect FE? What can we describe about point D? Can we say that point D blanks FE? Point D, if it's the midpoint, point D blanks FE. Yes, sir. Okay, splits them, but what's the word we talked about for splits? Bisects. Very good. Point D bisects FE. Okay. And what can we say about DG as well? What does DG do to FE? Because DG starts at point D, right? We know that point D bisects FE. What does ray DG do as well? It bisects it as well. Remember that a point, a line, or a segment can bisect a segment. Does that make sense? Okay, I'm going to stay here and I'm going to finish this next example so you can have it. You guys may pack up and go because I know you have another class. Just be a little quiet because I'm going to finish this up real quick so I can go to lunch. Yeah, put my styluses there. Thank you, guys. Okay. And then in the third example, we have that OK is congruent to KP. Label, label, label. OK is congruent to KP. So if I think about the conclusions that can be made here, we can say that K is the midpoint of OP. Okay? We can also say that K bisects OP. And last but not least, since line JM goes through point K, I can say that JM also is a bisector of OP. All right, guys? So I hope that makes sense. Hope your homework goes well. Thank you very much, and have a great day. Hope you learned a lot.